Cool. So let's get started. So, so today's class is about generative AI core or generative AI fundamentals that I have already taken yesterday. But I think most of the people were out, so I thought I'll repeat this session again because I haven't recorded yesterday's session. So far, what we have done as part of this specialization program. So we have completed Python, right? After that, we have also completed machine learning. We have also completed deep learning. And now, currently, we are about to start GenAI fundamentals and GenAI concepts. So, what we are going to cover in GenAI, I'll be showing you in a while. After GenAI, we will be covering agentic AI, and then we are also going to see popular agentic AI and GenAI frameworks like LangChain, LangGraph, and Crew AI, and we will do hands-on session. I'll do live hands-on coding, and we will create live AI agents. And after that, I will be covering the Gen AI governance or AI governance, I would say. But specifically for Gen AI, what exactly needs to be done as part of governance, we will be going to cover that. And then I will also cover the Gen AI adoption roadmap in any organization. And last but not the least, so one founder insight session I have promised you guys. So uh, it is about mindset engineering. So how do you engineer your brain to basically improve its cognitive ability? So we are going to see that. How do you basically switch from one brain wave to another brain wave as per the task in hand? So we are going to see that in mindset engineering session. So as of now, we are at this stage and we are starting GenAI fundamentals. Now, as part of GenAI fundamentals, what exactly we are going to see? So first of all, we are going to see what is GenAI, right? So it's a buzzword since last 2 3 years, and most of the uh, career shift is happening around generative AI. So it's applicable in every domain, whether it's software domain, networking domain, or even apart from software, outside the software, also in government sectors also. Generative AI is something which is, uh, becoming famous at a very fast pace. And you should be knowing the Gen AI fundamentals right from the beginning so that you can, easily adopt the uh, advanced topic as well, right? So, what is GenAI is something that we are going to see, and then we will see what are GenAI models, and then uh, what is GenAI architectures. Why I am referring these terms specifically is that because people often get confused between GenAI model, GenAI architecture. So we are going to see what are these. And then there are few other things so which I'll directly cover in the slides. So let's get started with GenAI. Okay. Okay, cool. So about GenAI. So if we are, if we talk about the definition about GenAI, so what is GenAI? So GenAI, first of all, is a AI, right? And there are two terms in GenAI: generative plus AI. So AI term is there. So for sure, it's a AI. It revolves around AI. And generative means the AI that generates new content. So in machine learning, deep learning, we have seen that the models that we make, they predict, right? They do some prediction. They are trained on some data set. They learn from that data, and finally, the aim or the final motto for training those model is the prediction, right? Now, in terms of generative AI, the final aim or the final motto is generation. So generation of new content. So this generated new content is either for direct human consumption or machine processing. So what we can do about with this new content, there are two things that we can do. Either the humans or user directly consumes it, or it is further used for the machine processing. So the example of direct human consumption is something if you are writing on chat gpt, so it generates new content, right? It every time generates a new content. It is not fetching from somewhere, unlike google, right? So google, what it do, it basically I mean the content is basically served on it saved on the server, and it fetches that and show that in a pagination manner, the pre-decided content. But in Gen AI, the main difference between Google and Gen AI or Chat GPT generated content is that the content that gets generated on Chat GPT is new content, and it is generated dynamically. And regarding machine processing, so sometimes what happens in the complex Gen AI systems, you are generating some content, and then generated content acts as a input to the next layer in that particular application. So that's why it is said that the generated new content is either for the direct human consumption or machine processing. Now, the generative AI is a concept which is inspired from human capability of content creation. So I think I have already covered it, but let me revise that concept again. So uh, first of all, this is the outer circle. Then this is the inner circle. Then and okay. So what is this? So this is AI, right? What is this? This is ML. Then this is DL. DL means deep learning, and then we have Gen AI. Okay. So AI is a superset of every other concept, right? So AI contains ML, ML contains deep learning contains Gen AI. So we can say that deep learning is also machine learning, and deep learning is also AI. Similarly, Gen AI, we can say that Gen AI is also deep learning. Gen AI is also machine learning, and it is part of AI. So this is how subsetting of these individual concepts look. Now, I have also shown you that AI is basically inspired from what exact concept? So it is inspired from human intelligence, right? So we are comparing the digital counterpart with the real world or human counterparts. Machine learning. Machine learning is inspired from what? Machine learning was inspired from human learning, and learning from what? From experience. And I have also shown you that human do learn from experience. Similarly, machine also learns from experience, but their experience is the training on the data set that we provide to them. Yes. Okay. About deep learning. So deep learning, from where the deep learning is inspired? So deep learning is inspired from um, human brain like learning pattern, right? So how the human brain neurons, biological neurons are present in the brain, how they connect to each other, how they, transfer or transmit the information between each other. That's how, from this particular concept, the deep learning concept is inspired. And we have also, seen the artificial neuron, how we build that artificial neuron, and how do we build the deep learning systems. Now, about Gen AI. So Gen AI is basically inspired from human creativity, or I would say human content creation ability. So like human create new content, human can create new content. Similarly, in digital counterpart, Gen AI also creates new content. So this is how the AI landscape looks when we fit in Gen AI in this. Okay. Okay. Now, talking about important terms in generative AI. So there are three important terms in Gen AI. First is Gen AI architectures, then we have Gen AI models, and then we have Gen AI models. So in these two, this is MODELS and this is MODALS. Now these, it's very important to understand what these terms mean and what exactly, I mean, different terminologies which comes under these different terms. Because what happens, people interchangeably use the word. so they basically switch among these three words and they interchangeably use. So let's see what these terms mean. Regarding GenAI architecture. So GenAI architecture basically refers to structural blueprint of GenAI system. So when I talk about a structural blueprint, so it's the architecture or a blueprint based on which the GenAI systems are made. Now, what are GenAI architecture? Different GenAI architectures. So different GenAI architectures are transformer, GAN. GAN stands for Generative Adversarial Networks. VAE stands for Variational Autoencoders, Diffusion Models, and Autoregressive Models. So whenever you hear about GenAI architectures, so you can relate that GenAI architecture. So there are 5 GenAI architectures based on which different GenAI models are made. So this is about GenAI architectures. The next term is GenAI models. And when I'm talking about models, I am referring MODELS, models with E in it. So GenAI models. So you guys have already learned that when we were talking about models in ML world, right? Machine learning. So models are basically the learned or the final mathematical formula that gets built after the training is done, right? So similarly here also GenAI models are AI systems and trained instances built using the GenAI architecture. So you are basically building some GenAI system, and that GenAI system will be built using some GenAI architecture. And once the system is finalized or built or the training is done, the final instance of that particular GenAI system is known as GenAI models. So what are GenAI models basically? GenAI models, uh, LLM, right? LLM is an example, large language model. So this is the most common example. Chat GPT and various other LLM based chatbots. So those are basically those are basically built using LLM, large language models. Second is image generation models. So image generation model basically used to generate or create new images. Then we have audio or speech generation model, video generation model, and multimodal model. So multimodal means where you can generate text, images, audio, video in any combination. So this is about GenAI models. Now, before we move to GenAI models with A in it, MODALS, I want to show you one line so that you can remember and we can discuss it after 5 minutes. So GenAI takes in vitamin C and generates vitamin C. Okay, so this line holds uh, I mean, a tricky significance, which I'm going to cover in another 5 minutes. But yeah, I just want to show you this line so that you don't forget about this line when we will be discussing it in 5 minutes. So GenAI takes in vitamin C and generates vitamin C. Now coming to GenAI models. So models here, MODALS. So model basically refers to type of data, MODAL. So in grammatically, if I'll talk, so it is basically the type of data is basically referred by the term modality, but MODAL gives more intuitive meaning to the whole GenAI concepts in the whole GenAI concept. So that's why I'm using the word MODAL. So MODAL model means the type of data. Now, if we talk about GenAI models, so GenAI model means the type of data that GenAI system can take in and generates as an output. And it is divided into two categories, input models and output models. So when we talk about input model, it means the type of data generative AI takes as an input, and output model means the type of data Gen AI system generate, right? So there are two possibilities only, right? If we have the Gen AI system, if this is a Gen AI system, it can take in some data as an input, right? So this will be input and it will generate some, output. So it is output. Now, type of data that it takes as an input, it defines input model, and type of output that it generates, defines or is known as output models. So this is what model means. Okay. Now coming back to the old, uh, coming back to the old slide, right, where I've shown you that GenAI systems or GenAI AI systems basically takes in vitamin C and generate vitamin C. Now, what is this vitamin C? Let's see that. So first of all, VI. So VI basically stands for video. T basically stands for text. A stands for audio. M stands for multimodal. Multimodal means the hybrid of all the other data. Multimodal, MODAL. I stands for image. And N I will cover in some time. Let's see what C stands for. So C stands for code. So in any Gen AI system, these are the different data types. These are the different data that Gen AI system can take in as an input, right? So you can provide video as an input, text as an input. So most common thing that we provide as an input is text, right? We chat with we talk with the chatbot and we are writing something. So most common thing that we provide as an input to Gen AI system is text. But videos, audio, images, code are something that we also provide the input to the GenAI system. Now, talking about N. So, N basically stands for, any guesses? Anyone wants to guess what does N stands for? Any rough guesses is also fine. Deepak, any guesses?
And for neural, as far as I know about
Okay, no. So N basically stands for numeric and system data. Okay, what is numeric and system data? So this is the data produced by some system. And when I'm talking about systems, so what are those systems? So when I'm talking about systems, so those systems can be the sensors, right? So data generated by sensors can act as an input. Then machines, different machines, right? And different computational systems, different devices, different monitoring tools. So there are monitoring tools and different, health related or medical equipments are there, right? So those are the sensors, devices, or monitoring tools that generate numerical and system data, and that data can act as an input to a GenAI system. So that's what N stands for here, numeric and system data. Now, let's talk about the output that it generates. So far we have seen what kind of input it takes. Now let's talk about the output it generates. So VI stands for same thing, video. T stands for text. It can generate text. It can generate audio also. M stands for multimodal. Multimodal means it can generate text plus audio plus video, in any combination as an output, right? I again stands for the same thing, image, and C also stands for code. Now, before I cover N also here, so out of these data that it generate, the basic output format, so basic output format or primary output format, I would say, basic output format in GenAI system that it generates are text and images, audio, video, and code. So these are basics, and if we collectively we collect these basic output format, then based on this we can say these are the type of Gen AI. because in literatures available on internet, in books, you will just see what are different types of GenAIs. So I just wanted to show you that the types of, when we talk about types of GenAI, so types basically covers the basic output format that GenAI system generates. And then the types of GenAI may, they basically mention text generation, image generation, audio generation, video generation, and code generation. Okay. Now let's talk about N in the output, GenAI output that it generates. So N here stands for next gen capability generation. What is next gen capability generation? So when we talk about next gen capability generation, it basically includes uh, okay, before that, why the next gen word is used here in this particular uh, definition? Because next gen is used because it's more advanced than basic content generation. Because basic content generation is simple generation of images and text, right? So that falls under basic generation. But next generation word is used here because it is more advanced than basic content generation, and these are the structured data generated by gen AI system that is meant for computational processing, simulation, or further workflow. Now, when we talk about next gen capability generation, so what type of different generation, next gen capability generation is there? So, molecule or protein design generation. So, nowadays, scientists are generating molecule and protein design using GenAI capabilities, and it generate new molecular structures. Then we have simulation generation. Simulation generation. Simulation generation means generating new simulation environments. And then agentic AI. So agentic AI that we will be, as part of next module that we'll be studying. So agentic AI is also part of next gen capability generation. Why? Because in agentic AI, the AI agents generates action, plan, tool call, workflow. So generation of action and plan is also something which comes, under the category of next gen capability generation. And then we have 3D or spatial model generation. So what is 3D or spatial model generation? So it basically, GenAI system nowadays generates new 3D object or environment based on the prompt. So you are providing prompt that, okay, generate me the 3D structure or generate me the 3D 3D apple. So it will generate a apple in a 3D format, and it will, that particular 3D generated, object will be the next gen generation using the next gen generation capabilities. And one another example is on demand VR generation from prompt. So you might have heard the word virtual reality, right? So whatever virtual reality that exists, the traditional virtual reality. So you wear one, what do you say, virtual reality headset, and you are able to see the virtual reality and anything related to virtual reality. But in next gen AI generation, uh, nowadays, you can generate the VR using prompt. What I mean is that, so you are providing prompt that generate a virtual environment, and you will give all the description of what kind of environment you want to generate, and it will generate the virtual environment through your prompt. So that also comes as part of next gen capability generation. So this is about GenAI models, MODALS, input models and output models, which you can remember by the line that GenAI takes in vitamin C and generates vitamin C. Any doubts before we move forward? Okay. So this is the basic of, data around GenAI. Now, next thing is next thing is A to G. Coincidentally, our cohort name is also A to G, which stands for agentic and applied and agentic GenAI, right? But A to G stands something different here. It is any to any generation. So A to G, that means any to any generation with respect to GenAI. What does it mean? Let's see that. Okay. So we have some basic data formats, right? So text, image, audio, video, code. So these are basic data types, right? Or type of data involved in GenAI. Then let's write it again: image, audio, video, code. Now, what does A to G says, or any to any generation says, is that so this is input, this is output, right? So from text as an input, you can generate text also. You can you can generate image also. You can generate audio also. You can generate video also. You can generate code also. Here your input is text, but you can generate all of these. Similarly, if your input is image, you can generate text from that image. You can again generate an image from an image. You can generate audio from an image. You can generate video from an image, and you can generate code from an image. Similarly, from audio, video, code also, you can generate all these basic formats, output formats. So that's what A to G means, or any to any generation means. Means you can provide any type of input, any type of data as an input, and you can generate any type of data as an output. So that's what A to G means, any to any generation. Okay. So I have taken some of the use cases here, uh, where I have mentioned input and output. Every possibilities that I have just shown you sometimes back, right? Any to any generation. So for example, if you are taking text as an input, then from that text you can generate text, image, audio, video, code also. If input is image, then from that image you can generate all other data types or all other data formats. Similarly, if the input is audio, if the input is code, if the input is video. So any to any generation. This basically covers any to any generation. Let's take some of the examples from this particular, slide. For example, you are giving text as an input and you want to generate audio as an output. So the use case involved here is text to speech narration, right? And 11 Labs is the tool which basically do that. So what it basically do, you are providing your prompt in text and it generates the audio from that prompt. Let's take another example. For example, from image to video means you are providing image as an input to GenAI system and it is generating video from that image. So animate the still image. I don't know how many of you might have used Sora or Runway tools, but Sora is a very famous tool where if you provide just an image, just a still image, it will convert that still image into a video or an animation. So that's an example of GenAI system taking in image as an input and uh, providing the video as an output. Let's take another example. Let's take the example uh, of audio to code. So voice to code generation. So what happens is that so you are providing some instruction to, and the tool used here is Copilot Voice. So to Copilot Voice, you are telling, okay, generate me a code to add two numbers, and you should also catch all the possible exceptions. So this I'm just instructing the Copilot Voice, right? So my input is going as an audio here, right? And once that audio goes into Copilot Voice, it will generate the code as per the instruction that I have given. Another example, um, let's say video to audio. So in video to audio, you are providing a video and then it basically extract the narration, or it basically adds the music as per the scene shown in that video. And Descript is the tool by which you can do that. And let's take, last combination here where you're providing input code as an input, and you can generate text, image, audio, video, code. For example, let's take this particular use case. You are providing code as an input, and output should be audio. So what use case falls under this category? Spoken walkthrough of the code. So you are providing your GitHub repository or your whole code to the GenAI system, and it will walk you through to that particular code step by step, file by file, directory by directory. So spoken walkthrough of the code is another example of code to audio generation. And 11 Labs is the tool by which you can achieve this. So this is about A to G, any to any generation, because in generative AI, input can be anything and output can also be anything. But so far, many people just think that text can only be the input, because 90% of people who are using generative AI nowadays are using simple chatbots, chat GPT, or Anthropic Claude, where they are providing just the text, right? So people by default think that only text can be provided as an input, but no. Apart from text, other type of data can also be provided as input, and similarly output can also be any of these data. Cool. Let's move to the next topic. It is GenAI model metrics. So GenAI model we have already seen, right? So GenAI model means the type of data. Now if we'll see here, the data type, these are the basic data type, right? Type of data, right? Text, image, audio, video, code. Similarly, text, image, audio, video, code in the output also. Now, what does model metric says that? So it talks about, so metrics, when I'm talking, it talks about numbers here. Numbers. So numbers or I would say combo in data combo in input and data combo generated in output. Okay. So when we talk about input, so total input you can give to chatbot can be one or more than one. So one ka example we have seen in the last slide, right? So where we have taken, see here the data is only one, right? You are just giving the text. You are just giving the audio as the input. You are just giving the code as the input. You are just giving video as the input. You are just giving image as the input. So that's what this particular category says. So whatever we have seen in the previous slide is the unimodal input. Unimodal means just one type of data we are providing as an input. Now we have something known as multimodal input. So what is multimodal input? So the input where the data type can be more than one type of data is known as multimodal. For example, if we give our chatbot as some instruction, so that instruction will be in terms of text, and I am attaching some audio also there, and apart from audio I am also attaching some image. So this particular use case where I am taking this as an input, this falls under the category of multimodal input. Multi means many, model mean type of data. So these are many type of data, right? More than one. So here it is three. So this is an example of multimodal input. Now when we talk about output, so output can also be text, image, audio, video, code, right? And total outputs, the data type of the output generated can be either one or can be more than one, right? So if it is one, then it's a multimodal output. And whatever we have seen here, here also we have seen the example where the output is just one type of output getting generated, because we want to drill down to every possibility. That is why we have taken just one type of input and one type of output in one row, right? So when we have just one input, it is known as uni-model input, correct? And when we have just one output data type as generated as in the output, it is known as uni-model output. output. So these examples that we have seen in this slide is an example of unimodal input and unimodal output generation. But we can have, many combination in this. So what are those combinations? So it can be, so we have seen that unimodal input, unimodal output. This is what we have seen in previous slide. Then we can have unimodal input and multi-modal output. Then we can have multimodal input and unimodal output. Then we can have multimodal input and multimodal output. Now these combinations, so these are four combinations, right? So when we so these combination are known as GenAI model metrics. So let's take an example, multimodal input and unimodal output. So multimodal input, let's say I am giving text plus image plus audio as an input, and I just want to generate the text in the output. So that will be the example of multimodal input, unimodal output. Let's take an example of unimodal input and multimodal output. So in this case, we are just providing, let's say, text, and from that text in output, it is generating image as well as video, something like that. So that's the example of unimodal input and multimodal output. So any possibilities of input and generation will fall under any of these four categories, and these four categories are basically all together forms GenAI model metrics. So this is about GenAI model metrics. So this is what I was telling, right? So we have unimodal input and unimodal output that we have seen, right? Text to text. Example is Chat GPT. Text to image. So from prompt, we are generating images. Similarly, if we'll take the example of unimodal input and multimodal output, so we are providing text as an input or image as an input, and in output, it is generating image plus audio. Similarly, if we'll take one more example where we are just providing code as an input, and from code, it is generating text plus image, means code documentation and architectural diagram. So that is an example of unimodal input and multimodal output. Similarly, there are other possibilities which I have listed down in this slide. So, for example, multimodal input, multimodal output. Let's take this example. So, audio and text I am giving as an input, and it generate video plus audio voiceover. So, it is like generation of your talking avatar, right? So these are all possibilities that exist in generative AI. So just don't limit yourself in just thinking that generative AI is all about textual generation or taking text as an input, because that's the first thing that comes in mind, right? So generative AI is all about generation of new content. That new content can either be text, image, audio, video, code, or next gen capability generation. Okay, moving on to next slide. So this is an important slide. Uh, okay, now how we basically proceed is that so we basically decide our generative AI, generative AI track or generative AI domain based on output model or the output it generates. For example, if the output modality, so I'm writing as output modality. ठीक है, output modality, if output modality or output model or the output generated is text, so this is text. Now when it is text, the AI domain that comes in picture is NLP. natural language processing. So what is this? This is AI domain that is in picture, right? Similarly, when NLP is there in pictures, then we can have, architectures, right? So architecture can be the traditional, because NLP is used in traditional AI also, right? So when I'm talking about traditional AI, it is pre-Gen AI era, when the Gen AI was not invented. So that is what is referred by traditional AI. So traditional AI architectures are there. And similarly, in Gen AI, when we'll talk about Gen AI, so Gen AI architectures are there, right? So Gen AI architecture, when we talk Gen AI architecture, so those are mainly transformers. Transformers. Okay. So this is how we decide the domain, or this is how we decide the correct path in Gen AI learning, or the correct path in Gen AI world. When we are talking about text, then the AI domain that will come in picture is NLP, and Gen AI architecture that will come in picture will be transformers. And apart from that, I also okay. So from the transformers, the Gen AI models, MODELS wala models. So Gen AI model that comes in picture is LLM. Okay, so that's how it looks. So output modality is text. The AI domain, the related AI domain will be NLP, natural language processing, and traditional AI structure architecture. Right now, I'm not talking. But when we talk about GenAI architecture, then the GenAI, the most important GenAI architecture involved is transformer, and the GenAI models evolved from this GenAI architecture. That is, the models that are built on transformers, using transformers, are LLMs. Okay, so this is how it looks, and that's what I have mentioned in this one slide. Similarly, if the text modality is image, then the domain, AI domain that comes in picture is computer vision. And so this is about traditional AI, which I will not explain here. But the GenAI architecture, when we talk in that case, will be diffusion models, VAE, GAN. And when we talk about GenAI MODEL model, they are known as image generation model, whereas in text, it was known as LLM. Similarly, it's for other output models, this is what how it looks. Okay, so this is about Gen AI uh, introduction, or Gen AI core. So we'll take a 10 to 15 minutes break. We will again, group up. And what I'm going to start, let me see what I have to start. So I have also, explained the concepts of NLP, but that is something, which you guys can also give it a try from your side. Nothing much. If you want me to take a session on NLP also, just let me know separately. I'll take one session on NLP also. But from in today's session, we will be discussing the LLM, large language models. So everything about large language models we are going to discuss. And then probably after that, yeah, okay. So after that, we will take prompt engineering. Okay. So let me start a timer for 15 minutes. You guys can, take a break for 15 minutes, and then we can, join in again after 15 minutes. One second. Okay, for me, for now, I'm just starting the timer for 10 minutes, but we'll meet up after 15 minutes. Okay, see you soon in 15 minutes. So guys, welcome back. Okay. So what we have seen so far, so we have seen GenAI core, where we have seen the concepts of GenAI architectures, GenAI models, and GenAI models, MODALS. We have also seen A to G, which is any to any generation. We have also seen GenAI model, sorry, model metrics. And we have also seen NLP concepts, yes, in yesterday's session. And now we will be going to we will be going to learn about LLM. Okay, why we are going in this particular format is that because we have seen the modality, right? Text modality. May what is the domain that we have seen AI may? It was NLP, right? So NLP we have seen, we have studied in yesterday's session. In NLP domain, what are the GenAI architecture or GenAI basically before architecture? We will discuss about GenAI model involved. So GenAI model involved is LLM, right? So GenAI model that was involved is LLM. So we will study LLM. Then GenAI model, this GenAI model LLM is built using some GenAI architecture, right? So what is that GenAI architecture? Transformers. So after LLM, we will see the concepts of transformers. Okay. And yeah, so that's why I am teaching in this particular sequence. So in case you get confused why NLP is taught before LLM or LLM is taught before transformer, so you can try to create this mental picture, because we are starting from the modality first, output modality, then we are going in to understand what is the AI domain in text modality, which is NLP. Then what are the GenAI models involved, which is LLM. So for LLM, what GenAI architecture is used? It's transformer. So that's how uh, we have. That's how I have basically planned out my whole training structure. Okay, so let's discuss about LLM now. What is LLM? So LLM. So LLM stands for large language model. So what is this? First of all, this is a type of NLP model, natural language processing model, correct? Because AI domain involved in this track is NLP. So this is a type of NLP model. So we can also call GenAI model for text output modality, right? And second is that it's trained on massive text data. So when I'm talking about massive text data, so different, it was basically, trained on the internet data, then different articles, whatever is, present, the text present over the internet. So it has been trained on all that data. So that, and, there are billions of parameters used in the training. Hence, billion means large. So that is why the name large comes, because it is trained on large data, as well as it is using, uh, you know, large parameters in itself in order to get its training completed. We have something known as uh, small language models also. So small language models are the models which is not trained on that massive text data. It's trained on relatively small text data, and parameters also are not that much which are there in LLM and compared to LLM. It uses a small number of parameters. Hence, the term small language model comes into the picture. So it was pre-Gen AI era when these kinds of models were used. Now, main task is in which the LLM is involved. So LLM learns patterns, right? So this pattern, so what kind of pattern we are talking here when we are telling that LLM learns patterns? So it learns patterns of language, it learns patterns of explanations, it learns patterns of reasoning, coding style, conversation, and it basically knows everything about the word knowledge. So when I'm talking about word knowledge, so everything that these models are trained on. You might have seen that when you are conversating with chat gpt, it basically chat as per the tone that you set up. If you are angry, it will try to console you down. If you want some motivation, it will also post some motivational quotes to you. So that's where this conversation and conversation style, coding style, reasoning, pattern of explanation, so it learns different patterns. And what are those patterns? So these are the pattern it learns, and it can perform many tasks, right? So LLM can perform many NLP tasks. So NLP task means natural language processing tasks. So what are NLP tasks? So uh, so NLP was existing in pre-Gen AI era also. So most of the task in which NLP is involved is answer question or Q&A, basically Q&A, and then summarize. It summarizes, it translates, it classifies sentiment. So when I'm talking about classify sentiment, let's say you have received any email, right? You have received some email from your boss, and you are not sure whether that email is positive sentiment, neutral sentiment, or negative sentiment. So you can just copy paste that email in chat gpt, and you can try asking chat gpt about its sentiment. So it will tell you about whether that email is in positive sentiments, neutral sentiments, or negative sentiments. So it basically finds the pattern of the sentiments also in the data. Then another NLP task is writing code and generating new text. So these are some of the NLP tasks that LLM can do. And as I said, right, why it is known as large? Because it's trained on large data, it have large neural networks, and it uses billion of parameters. Now, with respect to parameters, so we can have large language model, medium language model, and small language model. So let me try to draw a clear differentiation between these type of models. So when I talk about parameters, so parameters are nothing but the weights, right? You have seen we were using weights in machine learning and deep learning, right? W1 x1 plus W2 x2 plus W3 x3 till Wn xn. So parameters are nothing but W1 W2 till Wn. Okay. Now model name. So first of all, first model name is basically small language model. So small language model में parameters are somewhere around 1 billion parameters. Then we have medium language model. In medium language model, The parameter is somewhere around 7 billion. And then we have large language model, LLM. In LLM, we have parameters more than 70 billion. So 70 billion parameters are there in large language model, and how this is differentiated. You know, small language model, medium language model, and large language models. Now, these models basically read something, right? So when we talk about large language models, so these are large language models. It basically reads something. It reads something. So what is that it reads? So it basically reads tokens. So token is a very important term, right, in LLM and GenAI. So it doesn't, so LLM doesn't read words, it reads tokens, and hence LLM predicts the next token and not the next word. So whenever we are discussing about LLM, we talk in terms of tokens. Okay. So for example, I have shown an example in NLP also yesterday, right? If we have a word unbelievable, right? So what it will do, it will try to break this word into three tokens: un plus believe plus able. So this is how it breaks and reads in terms of tokens, and it basically predicts the next token, right? So this is what LLM reads. Now there is another term which is very important in context of LLM, and it is the word context itself. Context is a word which is used a lot in generative AI. So what is context? So context is the text that model can see currently, which includes. So first of all, context, what does context mean? So it basically means, or it basically consists of user prompt, then the previous message or previous conversation, previous message, then system instruction, system instructions, and RAG. So what are these RAG system instructions? I will cover it when we will do the live coding, when we will build the AI agents live. And then the examples we provide. So everything that goes in as an input to LLM consist, I mean, it can consist of different, subparts also, but everything that goes in generative AI system is known as context. And this context has limit, right? So you might have heard that if you are using as limit, if you are using some OpenAI APIs, so the limit exhaust after some time. It's because the context that you basically provide. Okay, so that is basically the token window I am talking there. But in this case, context is there is a uh, limit of words which you can send in at one time in the chatbot. So chat GPT mein you cannot paste or you cannot type it infinitely. So there is some limit which you can enter it into. I mean, based on which you can enter the text into that chat GPT. So that is something known as context limit. And uh, the from this limit, the limitation or disadvantage is that if the conversation become too long, if conversation become too long, then earlier parts are forgotten. Early parts are forgotten. So you might have seen that when Anthropic and OpenAI releases their recent models, they emphasize on telling that it has higher context limit. Why they emphasize that? Because they want to emphasize that this with this new model, we have the updated context limit, and you can uh, send larger amount of data as an input to their new model or new chatbot. So this is about context. Now training the LLM. How do we train the LLM? Training the LLM. So what does training means? What does training the LLM means? So training means teaching the model, right? Now, why I am bringing this topic is that, so see, right now we have pre-trained models. So Chat GPT is there, right? Chat GPT. So GPT is basically pre-trained models. These are pre-trained models. So pre-trained model means their parent company, OpenAI, is the company. They have built this model. They have trained this model. They might have trained it for some years. Once the model is trained and ready, then they have released this model into the market. So ChatGPT was launched in November 2022, and training might have gone. They might have training ChatGPT since years, probably maybe you know since 2019 or 2020. They might be training this model, and once the model is trained, they have released that into the market, and hence they are known as pre-trained models. So you don't have to train it, you just have to use it. But how do we train LLM is something that we will see now, or how ChatGPT guys or OpenAI have trained their model is something we will learn now. Okay. So what happens? Uh, First of all, the source of data. So we need some data source or data set to train model, right? We need some data to train the model. We have seen that in machine learning and deep learning also, right? So that data set, what modality of that particular data is applicable in this case? Mostly textual data or text. So this text basically serves as the input to those models. Now the source of data for this text is basically from blogs, from articles, from forums, from documentations, and from educational websites. So they have, collected all the blogs, all the articles, all the forums, all the documentation, all educational website available on internet, and then they have used that information as the input data to train the model. Okay. Now, how does the training usually happens? So first of all, they have collected the document. Now the training of LLM usually happen in a way where you hide next word. Okay. So they have provided this data and they hide the next word, and they will ask their model to basically predict. I will tell you, I'll give you an example here, but let me write down whole flow first. They will ask to predict. So if that prediction is correct, we will consider that the model has completed one of its learning, right? If the prediction is not correct, then model adjust the internal weight so that it is less wrong next time, and it will predict correct in the next attempt. And we have seen this in neural network, right? How does this happen? So the model calculates loss and gradient descent, and then using the concept of back propagation, it correct itself iteratively. So this is how the training happens for the model. You don't have to worry about knowing each and everything in this step. It's just that I want to give you the literacy around on how the GPTs or pre-trained models were trained before they were actually launched into the market. Okay. Uh, I have told you that training happens by hiding the next word, right? And it asks to predict the next word. For example, the capital of France is Paris. Let's consider that this is the word. So the whole, what do you say? Whole sentence will be divided into tokens, and so the tokens will be the capital of France is Paris. So these uh, will be the tokens. So the capi capital of France is Paris. Okay. So this will be how this sentence is divided into token. And now during the training, first the input will be given as, so let me write down here the input and label. So this portion denotes input and this portion denotes label. So first of all, the input given to this to the LLM will be the, and the prediction, next prediction, if it do is capital, the next word it predicts is capital, we will move on to next step. If not, then again it will go back, calculate the loss using the concept of back propagation, it will adjust its weight, and then it will do the prediction. So it will keep on doing the prediction till it will uh, adjust its weight and it predicts correctly. Then capital is predicted, so the capital will become input, next input, and then the expected prediction it will look for is off. So if it basically predicts off correctly, next label, then it will go to the next step where the input becomes the capital of. So this part becomes the input, and it will expect the output as France. So it will go on till it will predict the whole sentence. The capital of France is Paris. Now, if the expected prediction is not happening, then in that case, it will, using the concept of back propagation, it will adjust its weight until the prediction becomes correct. Now, these steps, all this process is happening during the training phase. I told you, right? So OpenAI guys might have spent some time, some months or years in training the GPT, right? So this kind of training is what might have happened during the training time of ChatGPT. So this is how they might have trained. They not might have. They have trained GPT during its training period. So basically, predicting the next token. I mean, the main concept behind the training is predicting the next token until the token is predicted correctly. So this is about how the LLM are trained. Okay. Now, I know there are a lot of theories since yesterday, and I wanted to quickly jump onto the prompt engineering concepts also. But I wanted to cover these, theoretical parts also because these theoretical parts, concepts are very important in order to know the background of generative AI. Now, some of the examples of pre-trained LLMs are, so pre-trained Pre-trained means already trained by their parent company, pre-trained LLMs. What are the examples? GPT, right? Any uh, GPT model, GPT-4o, GPT-5. These all are the examples of pre-trained LLM. Then we have DeepSeek. Then we have Llama. So Llama is basically Meta's pre-trained LLM. And then we have Claude also. Uh, so these are some of the pre-trained LLMs available in the market. Okay, so this is about LLM. So before we move forward, so Menti, let's start the quiz for today. And the winner of today's quiz will be awarded as the Menti champ of today. So everyone, please open menti.com in their mobile. Menti.com. Please open menti.com. I'll share the code which you have to enter there. But first of all, you can open menti.com. I'll pause for 30 to 40 seconds and move forward. Okay. Please enter this code, which you can see displaying on the screen, 61754837. Okay, two players are ready, one player are ready. So there are total 9 players. I'll pause for a while. Kindly join this code. Okay, I think 7 players are ready. So I think good to start. So let's start the quiz for today. So how I think everyone knows how it goes, but Supriya is joining for the first time. So Supriya, it's kind of a fastest finger first. So whoever answers it correctly and fastest will get the most point. And after 6 questions, so cumulatively, whoever performs best is the winner. Okay. So let's get started. So let me start quiz. Look onto your screen. So which of these defines how many neurons are there in a layer? Width of neural network, height of neural network, length of neural network, depth of neural network. Okay, only one person has answered it correctly. The correct answer is width of neural network. Let's go to the leaderboard and see who had answered it correctly. Boti Mac Boatface. I don't know who this mysterious personality is. Okay, let's go to the next question. Okay, 6 players are ready. Still waiting for one more player because we had 7 players, right, initially. Okay, now seventh player are ready. Let's start the quiz. Which of these defines how many layers are there in total? Again, options are same. The correct answer is depth of neural network. Five people had answered it correctly. Let's go to the leaderboard and see who had answered it correctly. Okay. So Boti Mac boat face is leading the charts. Let's go to the next question. Okay. Seven people are ready. Let's start the quiz. Here comes the third question. Which of these is not a cost function for regression? Uber loss, cross entropy, MSE, or MAE? We have discussed about it when we were learning about neural networks, right? Okay, the correct answer is cross entropy because cross entropy is a cost function used in classification. Okay, only two people had answered it correctly. Okay, Boti is still leading. Let's go to next question. Here comes the question number 4. Okay, this is something I think something did not got saved. Okay, which flow sends the error backwards in neural network? Gradient descent, forward pass, back propagation, cost calculation. I think we have discussed 10 minutes back on this concept. So I'm just giving you a hint. Just giving you a hint over it. The correct answer is back propagation, and everyone had answered it correctly. Okay, let's go to the leaderboard. Who had answered it fastest? I think Boti Mac Boatface answered it fastest. Okay, let's go to the last question. Which of these is not a target name in iris dataset? So we have discussed about it a lot. Virginica, setosa, tryptomen, versicolor. Okay, so correct answer is tryptomen, right? Virginica, setosa, and versicolor are three types of uh, iris flower mentioned in iris dataset, right? Let's go to the leaderboard to see who is the final winner. Okay, I think Boti Mac Boatface. Can you reveal yourself? Who is Boti Mac Boatface?
That's me.
Congratulations. Okay, nice. Cool. 2 minutes. Well, April. Sorry, I have stopped sharing my screen. Let me share it again. 12th April 2026. Meghna. Okay, so Meghna is today's Menti champ. I have edited your name. Okay, cool. So that's about today's Menti. Now, next topic is uh, transformers, right? Transformer is the architecture that we want to discuss. Okay. So before that, we will see the concept of self attention. So, self attention is a very important and revolutionary concept that got introduced. Attention mechanism. So, what is attention mechanism? So, the concept of attention in machine learning is how computer learns from data was inspired by human cognitive process, focusing on the most important parts of what we see or hear to understand things better. So, it is basically inspired from human cognitive process. That is, focusing on most important parts to see or hear to understand things better. Now, um, so in 2014, there was a person named Abhinav. He had introduced the attention mechanism in their paper, basically neural machine translation. And it was so there was a learn there was one liner which says attention is all that you need, and it became very famous because attention mechanism, based on attention mechanism, the whole architecture of transformer is based on. So what is attention mechanism? So attention mechanism gives more importance to certain parts of the input when making a decision instead of treating all the parts equally. And due to this attention mechanism, it improves the accuracy by focusing on the most relevant information. So basically, if there is some word, the cat is walking. So the cat is walking, it will give importance to cat and walking. The and is are little bit of less importance. So that is the whole concept of attention mechanism, where more importance will be given to certain part of the input and not to every every other part. So cat and walking will get more attention than the other words. So this is the basic of attention mechanism. Okay. Now, in attention mechanism, there is a concept of self attention also. So self attention is basically it helps the model to figure out which word in a sentence matter more, so it can understand the meaning and connection between them. So basically, uh, I mean, attention mechanism, self attention mechanism, both are same thing only. But these particular words, self attention, this particular word, self attention, becomes very famous when Transformer got launched. Okay. Now, how does it basically understand or provide the attention score? So, what happens is that, first of all, there will be a word or sentence. Okay. So, in this word or sentence, attention will be given to certain words more. Okay. And when we give attention to certain words more, we basically provide attention score. So this attention score is score that shows how much focus a model gives to each word in a sentence. Now, let's take an example. The cat chases the mouse. Okay, this is a word. Now, what happens is in this particular example is that the word cat has connected to both chases and mouse, right? Because uh, if you focus on this sentence, so what the cat is doing, it is chasing. So chases, and whom it is chasing? It is chasing mouse. So cat is associated with two words here in this sentence, chase and mouse. So as a result, the pair cat chases and cat mouse achieve high attention score, which tells the importance of a word. Because cat performs the action chases that we have already seen, and mouse is the object of that action, right? So the model identifies these relationship and assign higher attention scores accordingly. So in this sentence, when we associate with cat, so chases and mouse gets high attention score compared to the word the. Okay. Now the problem in the traditional AI models were that so it trouble. I mean, it basically there was trouble in understanding long range word relationship, and there was a trouble in handling large amount of data. So self attention basically solved these problem. How it solved the problem? It handles long range word relationship efficiently, and it lets the model process all the words at the same time, making training faster and easier to scale. And it assigns importance, as I said, right? Attention score. It assigns importance to input tokens like word, enhancing model focus and accuracy. So this is the attention mechanism basically. Now, when we talk about transformers, so transformer is type of a Gen AI architecture that basically reads the whole sentence at once and figure out which words are most connected. Okay. Now, okay, before we move forward, let me quickly show you one trick of remembering different mechanism or different components in transformer. Before that, let me write that word somewhere. Mm, transformer. Okay. Transformers is a word. Okay. Now we will try to decode different components of transformer from this word itself directly. Okay. Okay. So when we talk about, so first of all, take the word T. So what happens? T stands for tokenization. Okay. So whenever we are providing some input, so first, as a first step, tokenization happens, right? After tokenization, we basically do what we do. We do embedding, embedding, and the concept of encoding is there. What kind of encoding? Positional encoding. An encoding concept is there, so decoding concept anyways comes into the picture. So encoding, decoding is there. Now, after encoding, decoding happens, what is the next thing that takes place? The next thing is, okay, let me write it down in point number one. This is two, this is three. And next thing that happens in transformer, which is step number four, S stands for self-attention, right? So self-attention is another component. After self-attention, we have some concept known as multi-attention. head attention. So we have a concept of multi-head attention also in transformer. And this is step number 5, I would say, multi-head attention. And after multi-head attention, so this is a example of neural network only, right? So F stands for feed forward neural network. Feed forward neural network is one of the component inside the architecture of transformers. So this, let's give it a number 6. Okay, feed forward network के बाद we have uh, R. Okay, we will pick up the word R. So R stands for residual and layer normalization. Okay, normalization. And last step or last component, I would say, number 8 will be stack layers. So stack layers means these layers are repeated one after another, stack layers or stack transformer blocks, we say. So this is how you can, try to remember different components of transformers from the word transformer itself. So it has the concept of tokenization. So what is tokenization? So tokenization means uh, dividing the word into different tokens. Then uh, embedding and encoding happens. So it converts the input text into meaningful representation the model can understand. And that meaningful representation we have seen yesterday in NLP section, right? One hot encoding, bag of words, all those are the examples of embeddings, right? And encoding. Decoding, what does decoding do? It uses the encoder's output to generate the final output like translated or predicted text, right? Self-attention, we have seen what is self-attention just few minutes back. After self-attention, there is a concept of multi-head attention also. So multi-head attention means it basically helps the model focus on different parts of the input at once to understand context better. Self-attention and multi-head attention. So these are the attention mechanism used in transformer. Then we have feed-forward neural networks. So feed-forward neural networks, we already know what is FNN, feed-forward neural network now. Applies non-linear transformation to each token to learn deeper pattern, right? We have input layers, hidden layers, and output layers in FNN, right? Then we have residual and layer normalization, right? So layer normalization may stabilizes and speeds up training by normalizing value in each layer. And last but not the least is stack layers. So it builds depth in the model by repeating components to learn complex patterns. So these whatever tokenization and then FNN layers are there, it stack one by one and it creates more layers and create a depth in the model. So this is the concept of transformers, and I would say you can take the screenshot of this particular slide or particular concept that I'm teaching, because from the word transformer itself you can extract out all the 8 concepts or all the 8 components involved into the transformer. Okay. Okay, cool. So this is about transformers. I think enough of the theory now, and very interesting topic coming up. So we'll take 10 minutes break again. The next topic that I am going to teach you is prompt engineering. Now, prompt engineering, there is a framework that I have invented, and I'll be taking the IP rights on that, copyright acts. So that framework that I have invented is known as AI of prompt engineering. So what is prompt engineering and what is AI of prompt engineering? We will see after the break. And it is very, very interesting topic. And it is very, very important to learn also because prompt engineering is the base of generative AI, agentic AI, everything. If you know how to write the effective prompts, you know, half of the work is already done. So please attend that session in next 10 minutes and it is going to be very interesting. And we'll see how we can apply AI of prompt engineering to create powerful prompts and to enhance the output quality. Okay, so let me again start timer for 10 minutes and we will meet after 10 minutes. Hey everyone. Okay, so we are going to discuss about prompt engineering. Okay, so what is prompt engineering and why it is very important, and why basically, I mean, I would say it is the most underrated thing in GenAI, yet the most powerful thing. So people think that prompt creation is just writing and Googling, right? It is not even 1% what they are thinking. So, to understand what is prompt engineering, it is very, very important. So, what is prompt engineering? So, prompt engineering is basically the art of crafting well structured input queries to effectively communicate with AI systems such as LLMs or generative modules. So, basically, as I have told you, right, I have shown you that GenAI system take uh, input and then produces output, right? So that input can be of any format, image, audio, video, right? So the input that you provide to LLM basically is what is known as prompt. So prompt is the input given to LLM, and the way or the art of crafting that input is something known as prompt engineering. Okay. Now, why prompt engineering matters? Okay, very important concept. Why prompt engineering matter, or what is the importance of doing prompt engineering? So prompt engineering sparks creativity. It sparks creativity. What does sparks mean? So S basically stands for structure. Structure means it helps, prompt engineering helps in organizing prompt clearly with respect to role, context, task, and example. Okay. P stands for precision. Precision means it helps or it gives clear and specific instructions to AI in order to write the precise or in order to generate the precise output. A basically stands for accuracy. So accuracy means accuracy in producing correct and relevant outputs. So these are the advantages or benefits of proper prompt engineering I am talking here, right? Or why prompt engineering matters. R stands for reliability. So it ensures consistent and repeatable response. So if prompt engineering is done in proper way, it enhances reliability. Reliability means ensuring consistent and repeatable responses. K means K stands for knowledge extraction. Knowledge extraction means extracting new useful insights from models' learned knowledge. RAG is one of the example that will fall under knowledge extraction. S again stands for safety. So safety means when you are doing your prompt engineering properly, it reduces hallucination, biases, and harmful outputs. And again, this creativity is itself a separate term, which again stands for creativity only. So creativity means it unlocks powerful brainstorming and ideation. So this is why prompt engineering matters, because it helps in enhancing the structure, enhancing precision, accuracy, reliability, knowledge extraction, safety, and creativity. So this is the importance of prompt engineering. Okay. Now going to the next topic, AI of prompt engineering. So this is what I was talking. So this is the framework that I have invented, and uh, this is something when I was, creating the content for prompt engineering, I have invented this framework. So what is AI of prompt engineering means? So AI stands for the letter A to I, A, B, C, D, E, F, G, H, I. So this will give, uh, it basically denotes, A to I denotes the basic components of the prompts. So let's see what is AI of prompt engineering. So first is A of prompt engineering. So when I'm talking about A of prompt engineering, so A here stands for, first of all, act as A. So act as A means role. So if I am talking to a chatbot, I will basically start my query by saying, let's say, before I'm, start talking to chatbot, my first line should be act as a professional IT guy. What I'm doing here, I am providing act as a means role. So I'm providing role to the chatbot before I'm, writing further components in the prompt. Second A or second basically stands for, second A stands for audience. So audience basically is your target audience, right? So it means that, let's say if I write down as act as a professional guy, your target audience is, let's say, software engineers, something like this. So when I start writing my query and I'll take under consideration A, so A basically stands for act as a, and it also stands as audience. So role, there are different role. For example, teacher, educator, trainer, software engineer, QA, developer, product owner, fitness coach, therapist, lawyer, legal advisor, attorney, storyteller, writer, poet, whatnot, whatever you can think is possible. So that role you can assign to that chatbot and it will start acting in that particular persona. When we talk about audience, so audience can be anything, right? Children, teens, student, beginners, expert, intermediate, and then client, customer. So it becomes very important that you provide the role as well as audience to your chatbot. Now, this covers A of prompt engineering. Now let's go to B of prompt engineering. So B basically stands for base context. So base context means the knowledge base which we are providing to, what do you say, to the chatbot. So this knowledge base can be, some knowledge base document or some context that you are providing before writing your query. So for example, you are writing your query and in the base context, so let's say there are some HR policy document is there. So यहाँ पे you will start writing act as a HR specialist. Your target audience is the company employee, and your base contact is. And in this base context, you will either copy paste this HR policy document, and this HR policy document, for example, can be of 500 pages or any number of pages, right? But the thing is that you are providing base context. So this HR policy document will act as a base context, and then uh, that base context you are providing that in your query. So B stands for base context. Now going to the C part. So C basically stands for uh, the create command. So what creation or generation you need your LLM to do. So it will cover under that. So create, I mean, you will write act as a or act as a HR manager. Your target audience is employee. A base context you will give HR policy document. Now create top 5 HR policies of the company. So create. So what exact the query, exact query or the actual ask from the user comes under create C part, C of prompt engineering. So C basically tells about actual ask from LLM. So actual ask from LLM using the concept of NLP. So this NLP is different. This is not natural language processing. This is different. What is it? What it is? Let's see that. N stands for nature of task. I'll come to it in a while. L stands for level of depth. T stands for particular use case or particular target use case. Partic particular target use case. Now, nature of task, what does it mean? So, nature of task can be anything, right? Nature of task can be uh, informational and transformational or analytic, conversational, diagnostic. So, you have to provide the nature of task also in that case. So, uh, N part covers nature of task. Level of depth means the output that you are expecting from LLM, what should be the level of depth? Whether it's a surface level or deep level. For example, give me one line summary or give me a detailed step-by-step breakdown. So it denotes, so these two statement denotes level of depth. First was first example that I gave is at surface level. Second is at deep level. Now, next is particular target use case. So particular target use case means why you want to create, why you want, why you are asking this particular task from LLM, whether it's for decision making or it's for training or it's for public publishing, for automatic workflow, etc. So you can define that. Okay. So C stands for create task and C also stands for cognitive strategy. So cognitive strategy comes into the picture when you will play with agents or when you will create AI agents. So cognitive strategy is basically chain of thoughts and then tree of thoughts, TOT, MAR, multi-agent reasoning, self-consistency, REACT framework, REACT stands for reason plus act, self-reflection, COVE, POT. So there are many reasoning style or reasoning strategies. I'll cover it later on. But yeah, overall, C in prompt engineering stands for create command and cognitive strategy that you want to take. No, so first of all, I want to, focus on A to I, and then we will take an example. We will take an example. We'll see how we can form a poor prompt, and then how we can convert that poor prompt into a solid, high quality prompt using the concept of AI of prompt engineering. Okay, but first I want to teach you what A to I stands for. So this is about C part. Let's go to D. Okay, what is D? So D stands for do's and don'ts. Okay. So what is do's and don'ts? So do's and don'ts may you can mention, okay, so what should be the output format? Give me the summary in bullet list or in number list, or give me the summary in table, or give me the summary in markdown format. So output format will come under do. You need to mention what type of output format should be there. Then tone also. So you can say to chatbot that generate the output in formal tone, generate the output in informal tone. So tone may, what kind of tones can be there? Formal, informal, professional, motivation, sarcastic. So you can set the tone also. Next is uh, don'ts. So don'ts basically covers the constraints you want to keep. Cons Constraints. Okay, constraints. So constraint means give me the summary under 500 words. or give me summary between 700 to 900 word. So it basically contains word or character limit, right? Sentence limit, or any restriction that you want to give, vocabulary level. You can also ask your chatbot to generate, I mean, to use no jargons or no technical terms in your output. Theme constant, point of view, style rules. So these are the things that comes under D parts. That is do's and don'ts. Okay. Next is E part. Okay, what does E contains? So E basically stands for examples. So you can, when you are providing any, what do you say, uh, you are creating the prompt, you provide examples also, and it's basically divided into three parts. First of all, first part or first category is known as zero shot prompting. Then we have one shot prompting. Then we have few shot prompting. So zero shot prompting means where you are not providing any examples, zero example. Short stands for example. So zero shot means you are just asking, okay, generate me the summary for 2025, tech successes, something like that. So there you don't need to provide any example. So zero shot means zero example. One shot means you are providing one example to guide the output behavior. And few shot means you are providing more than one example to produce the desired output from the chatbot. So E stands for example. F. Okay. So F basically stands for, first of all, it stands for final thing to do with generated result. That means, let's say if you are generating an output, what do you want to do with that output? Either you want to save it in a PDF, save it in a feature file, you want to do AI chaining, you want to email the output, etc. So all those things will come under F part. Then we have final prompt construction part. Final prompt construction. So under final prompt construction, how do you construct the final prompt? Final prompt as JSON. So this is more applicable in coding. So when we'll be building AI agents using LangGraph, LangChain through AI, so it will hold more importance there. So there in your code, you want to generate the final prompt, right? So how do you want to generate that final prompt? So you want to generate that final prompt as JSON. You want to generate that, construct that final prompt using text file or using prompt template of LangChain. So everything comes under final prompt construction. So these two things covers F part of prompt engineering. Now F ke baad comes G. Okay, so what does G means? So G stands for, first is uh, gather good output. So gather good output for future base contexts or examples. So whenever you are working on some use case and you find out or you notice that the LLM is generating good output, then you should gather that good output and keep it as a base context or example for future prompting. And then G also stands for guardrails. So guardrails means guardrails basically what it means is that what AI is allowed to do or not allowed to do. So you are setting some boundary with AI. You are asking AI to allow some things to do, and you are also asking AI for something. You are instructing AI for something that's not allowed to do. So everything uh, those restriction or the rules that you want to make on AI will fall under guardrails section. So gather good output and guardrails are what G stands for. Now after G comes H. So H means it stands for how to avoid hallucination. So in order to hallucination, you need to provide some component or some part in your prompt, which will basically avoid the hallucination. So probably some of the pointers that you can write in the prompt in order to reduce the hallucination. So you can write something like that: reduce hallucination by following these rules. If you are not 100% sure, clearly say I don't know or suggest how to find answer. Second point, if calculation or reasoning are needed, show step by step. Third thing, keep the answer concise and factual, something like that. So you can, there are some set of rules, there are some set of points that you can write, which should avoid basically the overall hallucination. Okay. So H stands for how to avoid hallucination. I stands for, first of all, it stands for iterate it again if required. And second, it means incremental ask. So incremental ask means if you are doing some mathematical calculation or if you are seeking for some mathematical output, then you should ask the step-by-step generation. And iterate it again if required means if you are not satisfied with the quality of the output, then you can do minor changes. And for example, let's say if it is generating some output and then you want that output in bullet points, so you can increment iterate it again. You can ask, okay, generate the same output in bullet points now. So it will generate the whole output in bullet point. You again review it, and now you want, okay, this is looking long output. Then you will again ask, right, okay, keep the output in under 500 words, because you have forgot to add the constant initially, right? So this is what it means. So iterate it again if the quality, if you're not satisfied with the quality, generated quality. So I stands for uh, iterate it again if required, and incremental ask. And incremental ask is something which I have mentioned, right? A step by step ask in case of mathematical calculation. Any doubts? Okay, I think we can wrap up our session, today's session on this. Now, in next session, I'll probably cover what are different cognitive strategy, or probably I'll cover this when we will start AI agents and agentic AI concepts. So in next session, what we will do, we will construct some poor prompt, and we will then refine that prompt using this framework AI of prompt engineering. And then we will construct powerful prompt using this technique and see the difference in output that the chatbot will generate. That is first thing. Second thing we will study is about AI agent and agentic AI, and what are different concepts involved there. That we will see, and then we will have one Menti quiz also. And once it's done, I think we will be done with the GenAI theoretical concepts, and then we will, pick up LangChain example, and we'll take a use case. Uh, we will, build a capstone project using LangChain step by step, and so on. Okay, any final thing or any final thought that anyone wants to bring in before we wrap today's session? Cool. I think that's pretty much it for today then. Thank you guys. Have a nice weekend ahead, and we will meet in next class. Thank you.